Hi everyone, my name is Kartik and my channel is about mental models. Before I start, I wanted to say Happy New Year. Thank you all for your support in 2023 and here's hoping for an even better 2024. Recently, I have been focusing on cognitive biases as part of the mini-series, but I wanted to kick off the new year with a few mental models. And in this video, I will be talking about distribution. Distribution can mean to supply or give out something. It can also be a channel through which goods and services can flow to reach the consumer. But the distribution that I'm going to be talking about is the mathematical one. Without getting too technical, distribution is about how widely or narrowly spread out something is. So it's to do with the amount of spread. And it's the amount of spread from the average occurrence. So that's what I'm talking about. As we already know, mental models are tools, concepts, frameworks that are in our minds which help us represent and understand the real world in a simplified way. And this mental model is a tool by which we can understand better what is happening in a specific scenario, and by understanding the spread of what is happening, we can make more accurate decisions. This mental model is also important to understand as it's required to be better able to apply the probabilistic thinking mental model, which I will be covering in a later video. So how can we make more accurate decisions by understanding the distribution or the spread of something? The first concept is the term normal distribution. And this is represented graphically by a bell-shaped curve. Normal distribution shows that there is 50% of what we're measuring above the average and 50% below it. So it's quite symmetrical. So this is my axes and this is my bell-shaped curve. And this line, this vertical line here, through the highest point, is the average. And so what I'm saying is that this portion here that measures about 50%, and this portion here is the other 50% of what we are measuring. The second concept is, so that's concept one, the second concept is standard deviation. Now, in this graph, as we move away from the average, going down or going up, we cover more of what we're measuring. And standard deviation is split into one standard deviation, two standard deviations, that kind of thing. And so within one standard deviation of the average, we can see approximately 2/3 of what it is we are measuring. And in two standard deviations, we can see approximately 95% of what it is we're measuring. So again, if I draw my graph and I have my bell-shaped curve, and I have my average. So that's my average. Then this line here, this vertical line here, and this vertical line here, these 2 points are equal distance from the average, and this represents one standard deviation. So one standard deviation on this side and one standard deviation on this side. And the area, or the portion underneath the curve, this side of it is 34%, basically, of what we're measuring, and on this side is the other 34%, because it's the same amount either side. So that is one standard deviation. So within this spread, we can see 68% of what it is we're measuring. And similarly, if we go out a bit more wider, we go out another standard deviation more, either side, then if we capture this portion and this portion together with all of this, then what we have across 2 standard deviations is 95%. And so we can sort of half it. So it's about, I think, 12.5. So it's about 47% on this side from the average. It's about 47% on that side, and that gives you about 47 point something. It gives you about 95%. So that's what standard deviation is. It's how spread out something is. But one standard deviation is always showing about 2/3, 68%, and 2 standard deviations is always showing 95% of what we're measuring. So by knowing this aspect, you know how most of the performance is going to be. You know how 68% of the performance is going to be of the thing you are measuring. And this, in essence, can lead to better decisions. So, is that all for this video? Well, not quite, because the amount of deviation matters too. You can make a more accurate decision between many choices by understanding the distributions for each. And this is where this mental model shines. Knowing or understanding the average occurrence of something is not too difficult. Let's say we are planning to do some shopping. We may say something like, on average, it takes me 20 minutes. Or we may say something like, my average weekly spend is £60. We can usually provide an average for something with a very good degree of accuracy because we do it on a regular basis. But as the deviation from the average increases, the likelihood of something happening which is at the extremes, so at either ends here, that likelihood is greater. And we are less able to rely on the more common outcomes, which are closer to the average, represented by being closer to the average, than those that are further away. Let me just quickly draw that graphically. So we've got 2 curves. That's one. And this is another one. They're both bell-shaped curves, and they both have, for argument's sake, the same average. But for the red one, 2/3 is going to be out here somewhere. Whereas for the yellow one, 2/3 is going to be here. So it's going to be a lot closer to the average. And so if we have this scenario, we can make a more accurate decision because it's closer to the average. Whereas for the red graph, because there is a greater spread, our decisions will be less accurate because there is a greater likelihood of something happening which is at the extremes. So let's take two sets of financial data. Now, before I begin, this is not intended to be financial advice and shouldn't be taken as such. I'm only using this as an example to explain distribution, and what I say is purely informational. So I have two sets of data. So let's just say example. And each set of data has 5 data points. So I've got set 1 and I've got set 2. Set 1, the points are 555, 575, 600, 705 and 740, and set 2, it's 615, 625, 640, 645 and 650. So these are my two sets of data. Now I want to choose between the two sets of data, so I want to make a choice, and I want to go with the set that will give me the least surprises. And so I'm looking at the financial data, these numbers, to help me make this decision, which is somewhat non-financial. Now, I can work out the average for both sets, and the average for both sets is actually the same. So that's not so helpful. It's 635 is my average for both sets. Now, I can see that the data, just by looking at it, for set 2 is closer together and closer to the average. It is obvious, therefore, even without doing any calculations or doing any graphs or anything like that, that in set 2 there is less deviation. But when I do calculate the standard deviation, I will see that for set 1, actually I'll use a different colour, for set 1, the standard deviation for set 1 is actually 82, and the standard deviation for set 2 is actually 15. So you can see how much more narrower set 2 is than set 1. And I can clearly see that the likelihood of a data point being closer to the average in set 2 is going to be higher, and the likelihood of something happening which is at the extremes is going to be in set 1. So in set 2, any new data points that come in are likely to be closer to the average, whereas in set 1 there is a wider spread, so there is a greater chance compared to set 2 that it will be at the extremes. So ultimately, if I want fewer surprises, the choice that I'm making, I should go with set 2, and that will give me the least surprises. But this was very easy visually. Let's say, what if the data was a little bit more sort of together? So let's say again, two sets of data. Let's say one is 50, 60, 70, 80, 90. And set 2 is 66, 68, 70, 72 and 74. Again here my average is 70 for both. However, both sets of data are quite close to the average. Now again, we can calculate the standard deviation, and for set 1 it's 14, and for set 2 it's actually 3. And so what I'm saying here is, again going back to the concept of standard deviation, that within 14 points of my average, so 84 and 56, the majority of the data will be in that range, whereas here I'm saying the majority of the data will be between 67 and 73 if there is a data point. So again, I would go for set 2, because set 2 is a better choice because it is narrower in terms of its deviation from the average, so it is a better choice. And so we can see graphically, so going back to this, the yellow graph in both cases is represented by set 2, and the red graph in both cases, in my example, is represented by set 1. And we always want to try and go for a narrower deviation. So graphically, we can see that where the standard deviation is smaller, we are closer to the average. And so as we are generally good at measuring the average of something, a smaller deviation can lead to even more accurate decisions. Now, if we encounter situations where we can't understand how distributed the data is, then we could end up guessing wildly, and that will lead to inaccurate decisions. In some cases, taking a guess is the only way forward, but where we can, we should try and avoid that. Now, someone may be watching this video and say that things are not always a normal distribution, and then and data or things in life may be skewed and are often skewed. So what then? Well, when something is skewed, then the standard deviation may not be the best tool you can use, but you can measure the skewness and then apply this to the deviation. So let's say I've got another bunch of data. This is just random. So let's say, so for skewness, I've got a bunch of data. So this is quite evenly distributed, but I've got a bunch of information that's 2, 4, 6, 6, 7, 7, 8, 8, 8, 9, 9, and 10. Now, here, the average is actually, the arithmetic average is 7. And the most occurring, most frequent number, which is known as the mode, is actually 8. And the middle number, which is going to be here, the median, is 7.5. So graphically, this graph will look something like that. And we've got this here is your mode of 8. You've got the middle number of 7.5, the median, and you've got your average down here, let's say, which is 7. Now this is not to scale, which doesn't help me a lot, but this is the average that we have always used. So the standard deviation will be from that average. Now, if we calculate the standard deviation as I've done in sort of these two cases, then that deviation will be 4.74, so if you can plug in the numbers and do the maths in your own time, it will be, let's say 4.74, and it will be on the other side of the average 9.26, because the standard deviation is 2.26. But if we apply the skewness factor, and the skewness factor is minus 1.03, because this graph has a negative skew, and we apply that to this, we will see that actually I should use a different, yeah, here we go. If we minus this by 1.03, we will see that the line for the standard deviation is down here, which is 8.23, and the line on the other side is a bit further out, which is 3.71. Just extend this graph a little bit more. And so what we're saying is, initially these two lines here was our standard deviation, but actually in this portion, so just going up to the red, in this portion here, we are getting 34% of what it is we're measuring, and similarly this portion here, which is a little bit wider, represents the other 34%. And that is because more of the data is on this side of the average, on the left hand side of the average, compared to the higher numbers. Now, simplifying a little, the concept is the same as what I have mentioned here, but more information is, or more data points could be captured on one side as compared to the other. So that's why we do not need to go wider on the higher side in this specific example. This is a negatively skewed graph, but if it was a positively skewed graph, the reverse would apply. Now, this isn't a maths tutorial, so I haven't presented any formula for working out standard deviations or skewness. What I am trying to do is present the concept so that we can use this mental model to reach better decisions. The key thing to remember from this video is that the narrower the standard deviation, the better the estimate and more accurate the decision making can be, as the majority of the range of likely occurrences will be closer to the average. And that is distribution, and that is all for this video. Thank you for watching. If you like this video, please like and subscribe to my channel, and I will see you in the next one with another mental model. Thank you for watching. Bye bye.